my presentation is about Git. Just a few things that I collected through the years where I'm working with Git that I think it's useful and not everybody knows, right? So my name is Savio. I'm a software developer for more than 13 years now. I've been working with many other languages other than PHP. I'm mainly a PHP developer, but I love programming and I love to try different things, right? Right now, actually right now, but since I started with Git a few years ago, I got addicted to Git. So I even have one project that I intend to talk about it in a future meetup if possible, where I build a file system CRUD using Git in the background. So every record would be like a file system file with versions kept with Git. Crazy stuff. But yeah, that's me. And I'm going to talk about a few things that I think everybody should know. To begin, just to know the things that I can't skip and things that I have to make sure that I mention here. How familiar everybody here is with Git? Like, do we have someone that never touched the Git before? Anybody? I'm not hearing anybody. Nobody? If there is anybody that never touched Git, please say something.
I think everyone has touched it at some point.
Okay, so I will consider that all of you are familiar with the basic process of Git, so I will skip that for today then. And yeah, the goal with this is as soon as you can do something really fast, really well, you can start making different decisions. So based on this quote, when I started to learn fancier tools of Git, I started to work differently with it. So I think like by sharing this, I hope to help others to get better and to keep improving and get excited about this too, as I am. So to begin with, I'm not going to talk about the history of Git. I think all of you know, and it's not very interesting too. So let's start with the basic usage of Git. I think everybody's familiar, but let's go there. I was going to do like some examples with the command line here, but because everybody might be familiarized with Git, I will skip that for here. The initial process, like the basic process is you create a repository, you make file changes, you stash changes, you commit changes, and that's it. You have a version, you have a repository, and now every change, you can keep creating versions, and that's it. So Git is that distributed version control system that we all can rely on when it comes to keep versions of digital assets, right? The basic usage is this, is the local usage of it. When it comes to working in a team with Git, the process changes a little. So if the team already has a project, a repository, instead of creating one, you're probably going to clone a repository. And then you do everything the same until the moment where after you create a local version, you're going to push that version to a remote repository. So now we have two different steps, right? Like instead of creating a repository, you're going to clone from one. And then after you commit to a repository, you're going to commit to a remote one. So here, I think, because like ahead of on the same talk, I'm going to depend on a few details here. I will go over very fast on this on the remote subject here. So the command line. Where is my command line? Here it is. Actually, here. Yeah, I had this ready here. my Git playground. So I'm going to create a repository here very fast. So I'm going to create a directory, git sample, and now I'm going to turn this directory into a repository, git init. So now this is a repository. We can see, because now we have, oh, you're seeing the screen with my command line, right? Okay, so now we have this directory here, which means that this directory is a Git repository. So now, if I git status to see the status of it, I'm on the branch master, nothing to be committed. And I really suggest everybody, if you're not used to this, I really suggest you to get used to Git command line, simply because through the many years that I've been working with it, you can't properly control all the aspects of Git by using a user interface. Sometimes you have to go to the command line. This is my suggestion. Some people never go to the command line. I'm not one of those. I think command line is essential. And this is why all my examples here are on the command line. So now I'm going to just create a version because I want to show you the remote, how it works. So I'm going to create one simple file, test one, line 1. Now I have a file there. It's not tracked. I'm going to add this file. I'm going to create a version now. Now we have our first version. If we git log, we'll see the version. If we want to see what is there, we can use this ID that is right here with the command git show. This shows the difference. That's it. So now what I'm going to do is move forward with the remote principle here. What I want to show you is that we have two types of Git repositories. We have a Git repository where you have a working tree, and the Git repository where you don't have the working tree. And not everybody knows about this, so this is why this is my first tip about Git. This is the first thing that I want to share with you, that if you don't know, you should know about Git. And the type of Git repository that doesn't have a working tree it's called Git bear. Not bear the animal, bear like this, bear. I don't know if my pronunciation is wrong. So the Git bear doesn't have the working tree, and there's a reason for that. Working tree is this file here, for example. This is part of this repository's working tree. And if you list the hidden files, you have this directory here. This directory is where Git keeps all the information it needs to keep this repository. So why the Git bear doesn't have the working tree? Git, the repository, the bear repository doesn't have the working tree because when you're working in a team, you will come into a situation where you want to push your changes to a server where other nodes, I'm going to call other people that are working for the same repository as nodes, because every clone is considered a node in the Git network, right? So when you want to push some changes into a server or to make those changes available to the other nodes, if you are pushing those changes to a node that is not a bare repository, you will come into a situation where the Git directory, which holds the metadata of your repository, will have versions registered that you don't have in your file system. So for example, if I clone this repository that has a working tree into another one, let's do this. Git clone, git sample into git sample 2. Now I have a clone, right? So if I go there, and I can check it has a working tree. It's updated with the other repository. Now I'm going to do a change and push to the other repository. First of all, if I check which remotes I have, the remote is the other repository where I can push to, right? So if I git remote -v to list the remotes that I have for this repository, I'm going to see the repository that I cloned from. So if I make a change and push, it's going to push to there. As you can see, this is the remote that I'm going to push to. And if I pull, I'm going to fetch from there. So if I change this file, let's do line 2 here. And I will have a change. I will add this change to the next version. Then I commit, add line 2. Now I have one version ahead of the other, the remote. Now, if I push this change, I will probably get denied because the other repository has a working tree. And this is the situation that I'm talking about. So git push origin master. See, you're going to get denied because if you force this to happen, you can force it. You can just add this to the git config metadata file to customize the other repository to be able to accept this push. But if you do so, you'll get to a situation where when you push this version into the other, into that remote that has a working tree, you will get into a situation where the other repository, without having any change, the next time a person goes there and run git status, it will show a difference. And that person will be able to deny that version, like to undo that version without knowing about, like if somebody added that for a reason, or even that person might lose all the changes they might have there. So here's where Git bear repositories come into place, because the bear repositories are made for this situation. When you have to push to a remote repository, you're going to probably push to a bear repository. So an example of bear repository is GitHub, for example. GitHub, when you have a repository on GitHub, the GitHub keeps only bear repositories. Those files that you see there, GitHub is actually making them available for you to see. But when you push, like when you git push origin master and the remote is a GitHub repository, you're pushing to a bear repository. This is why you don't see this kind of message when you're pushing to GitHub. And the same thing happens if you're going to have like your own server. So let's see an example where we have a bare repository instead of a simple repository with a working tree. So I'm going to do the same clone, but I'm going to add a command here. There. It's because it already exists. Now I have a bare repository from that repository. If we navigate inside that sample bear, we will see that it doesn't have a working tree. It has all the content that you have inside any .git directory. So if, for example, if we list what we have inside that .git from the original repository, you'll basically see something very similar, right? It's because it's about the metadata that Git needs to keep your versions. So now, if I go inside that Git sample2 and change its remote to point to the bare repository, I won't get the push denied. So let's see that happening. I'm going to list the remote. That's the remote. I'm going to delete this remote. Git remote remove origin. And now if I list again, no remote, I'm going to git remote add origin. And I'm going to copy because the only difference is the dash sample at the end. Okay, the dash bear at the end. So now if I list again, I pointed it to point to the bear repository. So now if I git push origin master to push my changes there, it will work. So this is the difference between the Git repository that has a working tree and the Git bear repository. And this is what I wanted to show. And this is how you work with remotes. So if you've been working with GitHub since forever, you probably are not going to be entirely sure about this. And this is why I'm sharing this. If you know, probably that's not going to make much difference in your life, but I'm happy to be the one who share this at some point. So this is the aspect that changes here. When you're working with a team, you're going to have the extra step that requires a bare repository to be in place. So in usual development environment with a team, it goes way beyond just having a Git bare repository, right? You have also the situations where your changes conflict with someone else's changes, right? So for example, you're editing a file and someone else is working in the same file. And now you're going to push your changes, but someone else pushed their changes first to the same file. And it happens that both of you changed the line 3. Probably what Git is going to do is it's going to say, you don't have the latest changes, pull those changes into your node first before you'll be able to push your changes. And when you do so, when you pull those changes to your own clone of the repository, Git is going to accuse a conflict, and then you have to solve it manually. You're going to open the file. Git is going to show you by a markation those differences, and that's all. So I'm not going to run into that because I consider that you already faced this kind of situation. What I'm going to do here is just cover the basic strategy that teams go through to avoid those kind of things. So in my experience, the only good solution for that is to work with branches. So this is the basic Git flow strategy. Many of you might be familiar too. And the Git, the usage of branches makes available to you to have a secure environment while you push our changes to some place, and until you have everything that you want to do in place, you can keep like secure working without get worried about, oh, someone else is going to change the same file. The next time I pull the changes, I'm going to have a big conflict here. If you're working in a different branch, you're probably not going to have that problem until a later moment. And that later moment is probably a moment where the feature that you're working on is ready. And then it comes to that moment where you have to move forward with it. And at least you know that the part that you build is working before you get the conflict, right? So that's better. And then you can negotiate what to do there. So let's see a basic example of that. I want to show a basic example. So now I'm going to change the line 3 in the original repository. Remember that I added the line 2 in the clone 2, and now I'm going to change before pull the changes in the original clone to cause that conflict that I'm talking about. Just as an example. So now I'm going to add a strange line 2. And I have to also add this origin. So I'm going to run the same command. Because as you can see here, I don't have any origin because the other repositories cloned from this one. So this is why I don't have it yet. I'm going to, sorry. New keyboard, new changes. So now, see, now I have, and now I'm going to push. And that's it, rejected. Why? Because both change the same line and I don't have the latest update. So when I git pull those changes, conflict. Oh, actually, sorry, I didn't add the change. So let's add it, let's commit it. Now I'm going to push again. That's where I wanted to get to. So now I'm going to pull conflict. That's it. That's what I wanted to cause here. This is the conflict that I'm talking about. So now what you're going to have is both modified, and if you open the file, the git marcation where you have, where you have what is in the remote one and what is in the local one. So you can decide which one you want to keep. So the best strategy, as I said, is to work in branches. So until a moment where you have what you're working on ready, you don't face this kind of issue. But there's not much to do, right? You're always going to run into conflicts eventually. So people have some different approaches on that. Sorry, my keyboard is not sending there. Happening here. So people have some further strategies on that. For example, on the team that I work for, people have these constraints of we never merge up. We always merge down first. What that means? That means that you will never merge something into, like, for example, we have the master branch, which is usually the branch that we have in production. And I have a change in my branch called feature one. Eventually, to put my changes in the feature one branch into master, I'm not going to merge into master. I'm going to create a pull request, which is, I'm going to create a request on the repository, like let's suppose on GitHub, where people will be able to see, and only then that merge will happen. And then every other branch into the system will get those updates from master. They are not going to get from mine. So we're not going to do, for example, a merge from feature one into feature two. We are going to merge feature one into master, and then master into feature two. That's the constraint that we all have to follow in the team I work for. So people create constraints like that, so we avoid conflicts, and that's a very efficient one, I have to say. So that's the second tip, like use branches. So now I'm going to give my third tip when working with Git, finding changes. Finding changes are not very easy when working with Git. They might be easy when it comes to small changes, but sometimes like when we're refactoring code, for example, we have so many changes. Let's suppose that we are not just changing the strategy of the code, but we are also changing the code standards. For example, like we are changing how many spaces we have before the function, or how many lines we have from the top of the file to the namespace call, things like that. When you run the git diff to see the difference between the latest version and the current version, you're going to have a huge file showing many different changes, and sometimes it's going to be almost impossible to see those changes. For example, if you have something written wrong. For example, instead of one N, you have two N's. You're hardly going to see that without any tool. Like when you're running your eyes through the code, you're not going to see those type of errors, or how that was changed, or what is changed when Git accuses that the entire line is changed and you don't know where. So let's see a case of that. Sorry. I went to the last one. Okay, I'm here. So let's go there. Come on. Okay. So let's solve this conflict here. And then I git add, commit, solve merge conflict. Now I have a clean directory with the conflict solved. And what I want to show is, for example, let's suppose that we have this entire row here in that file. And we're going to create a version with it. And now I'm going to change this line here, for example, to have an extra O. When we run the git diff to see what is changed in the current status of our repository, we're going to see something like this. So this is a very simple example, but sometimes like you have entire paragraphs of explanation or some documentation or some code that you have like 300 characters, and you don't know, you're not going to know, like notice one specific character that is out of the place. So how you can do this simpler? There's a command on Git that is very useful, called in git diff, called git diff color words equal dot. So this is going to make Git differentiate not by line, which is its default way of showing the difference, but by character. And then you'll be able, oh, there's an extra O that shouldn't be there. Now you can git checkout to remove that version, and then it's clean again. So that color words command is a very useful one. I use it very often. I suggest you to use it too. So let's go to the next topic. Any questions until this moment? No? So let's go. Actually, there's one more thing that I wanted to talk about there, which is, I wasn't going to talk about it, but I think it's very useful, and I consider this an extra tip. When you're adding versions, when you're creating a version of your repository, sometimes you have like 50 changes in a file, and you want to add 15 of those. Like suppose like actually we have like 30 changes. You want to add 15 of those. You're not. If you want to add only 15, probably you're going to have a lot of work by creating a copy of this file, removing all the changes that you don't want, and only then staging those changes to the next version of your repository. So you have a better option than that. And this is what I want to show here. We have a clean repository here, so let's add this file. So I'm going to add a line here, and I'm going to add a line here. So now I have two changes. If I git diff to see the changes, I have two changes. And let's suppose that I want to add to the next version. I want to stage the first change, but I don't want the second change. Let's suppose that. So how I'm going to do, if the git add, when I use the git add and git status, I'm adding everything. So this is very annoying, because to avoid that, without knowing further how to split this staging action, we will have to manually remove those changes, right? So let's reset just to have those changes unstaged again. And the way to add one change and not the other is by using the git add -p. So this is what we're doing, -p. And then the name of the file. And what Git does here is it offers you changes in an interactive way. It offers you options in an interactive way to handle better what you're doing with the changes you have. So if you want to know what each of those options mean, you just type enter, it will show. You have many options here, but the option that I want to focus on is this one here, split. So now I can split, and then Git will ask me first about the first change. I can say yes, and then it will ask me about the second change. I can say no. If I git status, I will have the same file added and not added. If I git diff, I will see only the not added change, which is the one is here. And if I git diff dash dash, I think it's staged. Yes, staged. Dash dash staged, you'll have the change that is actually added to the next version. So if I commit, I git status, git diff, the second change still there, is not, like if we log the last version and show what is added to the next version, you'll see only one change, and that's how you organize better what you're actually adding to the next version. So I think that's very useful. I use it all the time too. I think this is very useful. So let's go further with the diff. There's one thing too about git diff. You don't have to use diff, the git diff, only inside Git environments. This is something that I didn't know until a few years ago, because usually when you git diff, you're expecting to show the difference of the current version from the previous version of the same file, right? But you can show the difference between two different files. You don't have to necessarily show the difference between the current file and the previous version of the same file in the repository. And this is so useful because the way Git works here, you can even show the difference between two different files outside any repository. And this is what we're going to show here. So let's go outside of the repository. This is not a repository. I'm going to create a test1 file. And this file is going to be test1. And I'm going to create a test2 file. And this is test2. And now I'm going to show the difference between those two files. How I do that? Git diff dash dash no index. And then the files I want to differentiate. And this you can do in any file in the system. And then it's going to show the difference. And you can even use the color words command to be even more precise about the difference. So this is very useful. And there's one thing too. I don't have an example here because I don't pay Photoshop. But you don't, because what I'm showing here is just the difference between text files, right? Simple text. It's not even like binary files or XML files like Word doc documents. I'm showing like difference between like simple text file, notepad files. You can use the git diff to show difference of binary files also. This is something that is not very known out there. And this is in the Git documentation if you want to search further. You can show difference between Photoshop files, for example. And the way to do that is you would configure, I don't have an example here, unfortunately. I intend to have this in the future, but you can specify how Git shows the difference. It's not necessarily a rule to always show this way. Git can create, can export, for example, images and open those two images in preview software out here. You can point an external software to analyze that difference if you want. You can do actions before the Git diff analyze this difference. So for example, you can export doc files into simple text files and only then run the difference between those exported files. So this is something not very known. It's not very easy to implement, but it's possible. If you have a use case for that, this is possible. So that's my fourth tip. I lost the count. So yeah, I actually had a slide for that. I forgot. Staging changes. I was going to show here, but I already showed. That's good. That usage of git add -p to stash one change and not the other. So you would have small changes being added instead of the entire file. So let's move forward then. Considering branches, I covered the case of branches before, but here's the moment. I suggest to you, never work on master branch, even when you're working in your local environment. Like you have only the only node in the network. You don't have a remote at all. You're working. I suggest to you, don't work on the master branch. And the reason for that is because for you to be able, like, it's not that you're going to need to use those resources, but you're not going to be able to use the full power of Git if you're doing so. Because the Git branches, the branches are there for a reason. So this is my suggestion there. And moving forward with the branches, I have this tool that I have to suggest, and I would like to suggest to you, the Git flow. And the reason for that, I'm going to make available this for you after, but I have the repository open here. And the reason for that is that usually when you're working with Git, you end up with a very polluted environment. You end up with a very polluted environment. So let's suppose that you're working on feature 1 today. You push those changes to the master, and then you create a PR, and then you don't have to work in the feature 1 again anymore. It's done, right? So tomorrow you work in the feature 2, and like that goes for 30 different features. And now you have 30 branches without any usage. You know, like it's polluting. So if you do some command like this, git branch, oh, because this is not supposed to. If you run git branch, for example, to list all the branches you have, you're going to have a list of 30 branches here, and the only useful branch for you right now is the master, for example. So, and once you commit your feature branch, once you push your Git feature branch further forward, that branch get useless, right? Once you merge it to the master, everything is on master. So you don't need that feature branch anymore. So usually you're going to do something like git branch -d to delete locally, minus the uppercase to delete remote, and the name of the branch, feature 1, for example. And this will delete that branch. But it's very annoying to do that every time. And you are not going to remember that every time. So not just because of that, but this is what this package here does. So this Git flow is actually a tool that automate this kind of test. There are many other tests. For example, how you name your branches. The name of the branches are very important when you're working in big teams, because sometimes like we have 5 different developers working in 5 different feature branches, and in the next sprint, you're going to have 5 other branches. And when you want to know, for example, when that work got done, or which task is that branch for? So you're not going to ask that guy because probably that developer won't remember what was done like 6 months ago or even last week. So the way you name your branch can be very helpful. So standards like that can help you. So right now we have like two different situations, or two different reasons of why you should be using this package, right? The fact that you will not always remember to delete branches that are not useful anymore, and the fact that sometimes the name of the branches matter. And not just that, is the flow too. So for that, this package here help you. For example, you're going to start a new feature, and then you can start a feature like this, set the name, and then you want to publish the feature. It goes like this, and then you can follow the documentation to see further. You can finish the feature like this, things like that. So this package helps you to do all that cycle without having to manually run the specific Git commands or procedures into the environment, in the network, in your repository network, to accomplish those things. So standard names, the workflow of Git, how you publish, when you publish, which branch are you going to push to, things like that. This can automate for you. This is my tip here. So let's go there. Deploying with Git. This is my last tip for you today. And this is the most important thing for me, actually, in my personal projects, because I don't have a very fancy environment to put on production things like my personal website or some ideas that I have. You know, like for example, I have a new idea of an e-commerce. I want to show to my brother, and I want to keep updating that website there without having to manually SSH into the server or use like an FTP or something. You know, like I don't want to keep going there. I want to run a command line on my local repository, and I want those changes to be available in production. I want to do the deployment in the most simple way possible. Git can help you with that. And this is what I want to show. Oh, actually, no, here. So for that, I prepared a few examples here. It's this here, example bear, example dev, and git example prod. And I have prepared here, which is, this is on the way. Okay, here. This gist here is an example of the deployment that I'm talking about. It deploys using the Git hook. And this is the shell script. You can read this later. I will make it available to you. And this is the shell script that you put in your hook called post receive in your repository to be able to do such. And I'm going to show how I did it here. I did it as a very small example. This is what I do on some projects of mine when I want to test, I want to iterate through a few cycles until I have something that I can see to decide whether to go farther or not, things like that, small projects. But I would do that in production in any project if I was the responsible for the DevOps part. So what we have here is, this is the Git bear repository, and those two here, this simple dev. Please let me know if you're not being able to see my screen properly. This git dev, example dev, and this git example prod, they are two clones of the same one. But the purpose of the git example dev is for me to work on, and this git example prod is kind of my production. Let's suppose that this is not here. Let's suppose that you're not seeing this here. You're seeing a directory that is actually in a remote server. This get bear would also be in a remote server. Let's suppose that this get bear here is in a third server. Like this is here, this is in server 2, and this is in the server 3. So my production is in the server 3. Every time I make a change in the git example dev and push to my bear repository, those changes are going to be automatically deployed to the prod. How I do that? Actually, I said something wrong here. The git bear for the deployment must be in the same server as the git example prod, just in another directory. So what we're going to do is this. If we go in the git example dev and we list the remotes, you're going to see that the remote is this git bear. And the name of the remote is production. Why is that? It's because this is not going to be a remote for me to share these changes to other nodes in the network. You can have more than one remote if you want. So for example, git add remote. Let's add as a remote. Oh, what am I doing here? Remote. Oh, it's remote add. Let's suppose here that like this is also a remote. I just added a random remote here. So if I list remotes, I'll have two remotes now, the origin and the production. You can have any number of remotes. The thing here is that I'm showing you a different usage of a remote. And the usage of a remote here is for deployment and production. This origin could be, for example, GitHub. So this origin is the remote that you push to when you want to make these changes available to other developers. But this production here, only the DevOps guy will have. And this production here is the remote that you push to when you want things to be deployed. So this is the thing. If I get status this repository, let's see this working. Let's see what I have, test. So let's change the test file. Let's add the line 4, line 5. Now I have a change. Let's see how the test file in the production repository is. So let's see, in example prod test. It doesn't have the line 5, right? So at the moment, when I push this to the remote called production, these changes are going to be deployed to the production repository. Let's see this happening. Git add test. Let's see, it's staged. Git commit. Change line 5. Git push. And here it goes. Production master. And now, if I see, I'm navigating. I'm going to show here the same file, but in the production directory. Line 5 is there. So this works like this. Let's go there and see. If we go into the bear repository, oops, sorry, I used theme. Let's go with theme. Like if I go there, you'll see that we have a few metadata files, right? We have to go on hooks. Hooks is the directory inside the .git directory when you're working with Git repositories, where you have your hooks for you to customize how Git handles stuff. So right now, what we want to customize is what Git does after it receives an update. So after someone pushes something to this repository, what Git is going to do. So to customize this behavior, we use this here, post receive, right here. And this post receive is the hook that is prepared for that. As you can see, Git has many other hooks that you can customize. But for deployment, we're going to show this one. So if we go there, you can see that this is exact the same code that we have here. The only thing that I put this to point to the production directory. So I'm not going to go into the details what this share script does, but the thing is, it basically goes on the production directory and pull the latest changes. This is basically what it does. So this is a case of a hook usage, a Git hook usage for automated deployments. And for that, we used the feature remotes. So we could push to a specific remote for the deployment, and the other remote would be used to share those changes with other developers. So this is my tip. You can use Git to make deployments. Let's move forward. Actually, any questions about that? Nope. So other things. When you're working with Git, sometimes, and this is very common on open source projects, but not everybody is familiar with that. So this is why I'm mentioning here. You might want to version your repository. The reason for that is because you want to create landmarks in your project for you to know the progress, the difference, and then you can offer support for specific changes, right? There are many other use cases, but I'm just thinking about that. So for example, you want to make a change that is going to probably make, to break things for your clients that doesn't want to update, that don't want to update. So to be able to avoid your project to break things for those clients, a version, to use the version strategy, it's a very useful one. So you, for example, it's going to break things, probably it's a good idea to use the first part of the version. So I have this here. This is called semantic versioning. There's a huge explanation here of how you should do and why. And it's basically this major version, like the first item in the versioning is major version when you're making compatible changes. The second number is minor version when you add functionality in a backwards compatibility manner. And the third number is a patch version. So you're basically fixing bugs. So this is my tip, use versions. How you do that? We're going to create a small version here. So let's go into that Git sample. So now we have this state here. We have a change, but I'm going to create a version before this change. So I have a landmark. So the way to do that is git tag. I might be wrong here, but I think it's this. V 1.0.0. That's it? No, I just forgot. So when you forgot, like I did right now, git tag documentation. Documentation. And you're going to find as first result this git tag. And this is git documentation. And then usually what I do is I like the commented version. So I can explain what I did and what is there. So let's go somewhere. Minus V, yeah, here. Actually, it was right in the beginning. Oh yes, it doesn't have space. Oh, sorry. I might be missing something. Where is the comment? Yeah, probably is going to do something like this. Oh, actually, yeah, this is what I wanted. Landmark one. Now, if I list the versions, I have this version here. And every time I add a change, let's add that change that is not stashed until now. Or version after tag. So I can add the version 1.0.1 and mark after 1. So now I have 2 versions. And I can go back. The tag works basically just like branches, but is a different marcation. And on GitHub, it's better visualized. It has many other advantages. I'm just saying that you can work like if it was a branch. But in GitHub, it's going to show right here. See, this open source project is also using the same. And the branches are here, so you can work on them. See, feature, they use standards, and the tags go here. And the tags are, for example, here you can see that there are no major changes for this project, but many other projects will have like version 1, 2, 3, 4, 5. For example, Laravel is on version 8, right? They're about to launch the 8. So this is my use versions to mark your projects when you're working with Git. The post receive hook is that hook that I just showed to deploy. And with that, I conclude my talk. I hope that you're not bored. This is my Twitter, and that's it. I hope you enjoyed. If you have any question, please, this is the moment. How can I stop sharing my screen? Here. How can I stop sharing? Oh, stop sharing. That's it. Are you still there? You're not sleeping, right?
That slideshow, is it available somewhere?
Oh, I'm going to make available. I'm usually putting in the. I'm going to comment in the Meetup app. I created a repository on GitHub where I'm putting my talks there. So I put available there a talk that I gave last year. I'm going to put this one there also, and I'm going to comment on the Meetup app. But if you want to know right now, let me put here in the chat.
One more thing, that you talk about the conflict at the beginning of the mean, but who has the final say at the end if there is real conflict between two presenters?
Sorry. Okay.
At the beginning, when there is a conflict between two studies or two posts, but who has the final say? How does the conflict get resolved?
Yeah, in that case, someone will have to jump in and solve that conflict, right? So let me share my screen again real quick. Just try to show an example. So let's create a conflict again. I changed something here, right? Let's see the last version. Log -1. Let's show this version here. So I can force the conflict. Let's force this conflict. So I added line 5, right? So let's go on, let's git push this, first of all. And let's go on the other repository and cause a conflict. Let's change line 5 there. Oh, there are many versions that they don't have here. Oh, fine. So get add, get commit, origin, conflict. What? Didn't cause conflict. What's happening here? The world is wrong. It's simple bear. This is suspect. Oh, let's see. Did I push? Everything up to date? Oh, yes, I didn't push, sorry. So I have a conflict. So when I pull, I'm going to have the conflict locally. So I can solve this issue before I push, right?
Okay.
your question is how we can solve this issue, right? Like,
Yes.
we have Git have this markation which shows what you have in the head, which is your version, your local version, and what you have in the remote repository that is out there that you have to merge with. So eventually, to solve this issue, someone like probably you, if you're the last one to create a version, you'll have to go here, open this file, see these changes here, see this markation of Git, and you have to manually go like this. Okay, my version is going to overlap the other person. All right, you go here, delete this line, delete, 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 delete. And then you save. You see that it's still like in conflict, so you're going to stage. You're staged. So push origin master. Oh, sorry. Commit merged. So now I have this conflict solved. What I did is I pulled the version. It showed the conflict. I opened the file. I saw the Git markations. I changed manually those changes. This is what you always have to do. If Git can't handle those automatically, Git usually handle those automatically. But if the changes happen in the same lines, you will have this conflict like this, and then you have to handle it manually like this. And then you commit normally. This will cause this to show something like this, which is a merge commit. So if you git log -1, you'll see that it's a merge commit. See, it's merge here, and it has the two versions that got merged and the current ID of the merge. If you want to undo this, you can just undo like you would do in any other environment. I'm going to do this after, but like if you git push, for example, origin master, this merge conflict that we just did, you can merge now because you already solved the conflict in your environment. Now you're going to the other one and pull there, and we'll see that the conflict is solved for everybody now because you solved locally before you push. So if I git pull origin.
So it has to be solved locally always.
Sorry?
It has always to be solved locally first.
Yes, always have to be solved locally. Someone will have to pull the conflicting version to his own local, solve it there, and push again to the remote repository, to the shared repository.
Okay, thanks.
Welcome. So yeah, that's basically what we have to do. The conflicts are very annoying. They will always happen. There is no magic end for them. They're like, it's easier to handle them when you have a better workflow. But you'll run into them anyways. So some people like the user interface because some user interface, for example, on GitHub, if you have a conflict during a pull request on GitHub, for example, GitHub will show in a very visual way the difference between those two. But it's going to be basically that markation that I just showed you, but prettier. And then you can manually edit there. Some other softwares, for example, PHP Storm, it shows in two different files. So you can choose which changes you're going to pull into the latest version. Instead of showing in the same file like GitHub does, and like Git does in the command line, PHP Storm will show into two different files. So every user interface will have a different strategy. I prefer to Git command line because Git command line never failed me. That's
Thanks.
welcome.
Did you say you're going to post the slides in chat?
Oh yeah, I forgot. Let me do it. In the chat. Let me make this public too. Oh, actually saying that anyone who has the link can access. Okay, so let me know if you can access right away. I put in the chat there. It's to everyone.
Yeah, it works. Thanks so much.
Welcome.
Great.
Hey, Savio,
Yep.
Bob posted a question there. He's asking whether you use PRs.
If I use, if so, yes, I use PRs, and I'm not exactly sure the nature of the question, like, because the way I work with PRs on my day-by-day work is that once I have my branch ready, like I receive a new task, I create a new branch, then I work for that task, that branch, and then I push that branch into GitHub, and then on GitHub I create a PR, right? This is the way I work. So once I create a PR, GitHub will show in a very fancy way the changes, and then all the other developers, they can criticize and they can ask changes. They can do their own commits if they want, because the branch is already there, right? And yeah, and then like only when everybody like get to a consensus that that is the best for the future of the project, the feature is working well, it's got tested, and all the standards accomplished, then we merge. So that's how I would do. Is that what you asked? Oh, oh, I'm not hearing you. I'm not hearing you, Bob. Are you muted?
No, he's not muted. At least not on our controls.
Oh, maybe you have to select which microphone your system is using. Like go in the audio in the top and check there. WebEx must use, like you have to select the microphone on WebEx app too if you. Before the meeting. What is Squash? I don't know Squash. Hey, Bob. I'm not hearing Bob.
I guess we got some technical difficulties there.
Yeah.
Oh, there we go. Seems we're all down.
Oh, you mean like if I change the comment in the commit? Oh, the Squash commits. I never heard of this Squash expression. Oh, I see. I see. Is there a way? And I'm not familiar with this here, but I understand where it goes to. Because like this is those constraints that I was talking about. Like some people to make it more understandable. For example, when you're going to show the history of the commits, for example, you want to understand the process of the code, right? So, and if everybody can comment with any wording, it's going to be a mess, right? So usually people like edit those comments. Also, there are many other actions that you can do too. The rebase is an alternative for merge, actually. People use rebase. I don't use rebase on my work right now. Oh, I heard something.
I think someone just left.
Okay. So I don't use rebase on my work, but I worked in the previous company that I worked for back in Vancouver. They use rebase all the time instead of merge. I can't say much about rebase because I didn't use, but I know that a lot of, like, it's kind of a consensus, right? That rebase is better. But there's a way for you to edit your commits outside of the PR, which is the command git amend, where you can edit the history of your versions. So let's suppose that you're still in your environment. Like, I don't know how to do that on GitHub. I'm probably going to take a look at this question. But if you're working locally in your machine and you want to edit the text that you have in your commits, you can use a command called git amend. This is what I know. Git amend, like this. And this command will make available to you to edit your previous commits text. So yeah, that helped me in the past. Probably this will help you if you're working locally. But probably what they are talking there in the WP read is about some strategy to work when you're working with teams, right? Let me know if I'm wrong. Yeah, most recent. Oh, yeah. This chat is so small. How can I make it bigger? Let me see. Where's the chat? Just a second. Oh, yeah, here. I have to use full screen to be able to grow this. Okay, git amend is for the most recent. I'm not sure, because I didn't need to change way back, like many history back, but there are probably some commands to do that. Yeah, that is for commits not pushed yet. That's it. That's right. But if you pushed, you still can edit the latest one, even if you pushed. That I know. Rewriting history, yeah. Oh, the rebase one. Yeah. Yeah, I'm not familiar with the rebase, so I won't say much. But yeah, probably the rebase is a very fancy tool to deal with conflicts too. It's not just for rewriting history. Nice.
Maybe we should take it a point to wrap up here now. Unless there's any more quick questions.
Is there any other question? Yeah, no, probably for the future, I would add rebase to this talk when I'm more familiar with it.
Well, thank you everybody for coming out tonight, and we'll hopefully see you again next month for another session. I think we will be online again. Not sure when they're going to be letting us out of our cages, but I think it's going to be a little ways down the road yet.
Yeah.
Thank you, Savio.
Thanks. Thank you. Thank you, everybody.